Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Dynamic NAT is our next one. Dynamic NAT, like we said, will use a pool of addresses. However, the pool has to be as large as how many addresses we have. So dynamic NAT will use mapping inside local to inside global addresses. The NAT, you'll use a pool of addresses. If we use all of the global addresses, then the next sending device will have to wait until there is an open address. If all the addresses in the pool are used, again, waiting has to occur. How do we configure this? Well, we're configuring a pool of addresses now. So step 1, to find the pool, we will do an IP NAT. We will use the pool command. We name the pool, and we give it the source. We'll give it the starting range, end range, and the appropriate network mask. We will also then provide an access list. The access list will allow us to filter what addresses can use this pool. And then we will set our IP NAT statement. So IP NAT inside source, we're listing, provide the name of the ACL, and provide the pool and the pool name. That will say this is the matching addresses that can use this pool. That way you can disseminate which one is going to be allowed and which one will not be allowed. It's binding the ACL for use with the pool list. And again, we have to identify which is inside, which is outside interfaces. How do we analyze? The exact same process. We walk through it logically, looking at source address, destination address for our addresses as they flow. And we should make sure that we can understand the logic as they return. And how do we verify? Show IP translate. We can also do a verbose option. If we do a show IP translate verbose, we get a little bit more detail. And again, we always have our show IP NAT translate, we have our clear command, and we can also look at our statistics. And that way our statistics will show what is being allowed, what's being allocated, total addresses being used, if there's misses. And lastly, we can always look at our show command, our show run command, to look at what is happening in the show run. And again, we have a lab verifying and walking through dynamic NATs. PAT is our next big one. And again, PAT is port address translation. And this one is probably going to be the one that you really need to pay the most attention to. I've used static NAT and PAT the most, and I normally use them in conjunction with one another. We'll be setting up an IP NAT inside source, setting up the appropriate ACL, but this time we're giving it an interface, and we're also issuing an overload command. The overload basically says we're allowed to overload how many addresses we have. We may only have one public address, but we're going to overload that public address with multiple ports. We create the ACL, realistically create the ACL first, then do the NAT table, but everyone's slightly different. And again, make sure that you identify which is inside and which is outside interfaces according to NATs. So once we've done that, and we've also set up our overload, we can ensure that our ACL is there, and we can start translating. How do we analyze? Again, we walk through the logical process, but this time pay attention to the port numbers. Normally, we're going to be looking at the source port number as it leaves the original source, because that's going to be a randomized port number that will be used to identify the inside local address. Again, when it is responding back from a web server, for example, the web server is probably going to be responding from port 80, and that means the new destination port will be the appropriate destination port that would be matching from the original source, if that makes sense. So here's our original source. On our return trip, it's going to be looking at whatever is our destination port, and that will let us know which one of our communication strings it is attached to. And again, we walk through the exact same thing. We analyze two different strings with our PATs. Verification, show IP NAT translate. We can do our statistics as well. And again, we have a packet tracer walking us through how to configure it for verification. So lastly is NAT64. You can use NAT for IPv6. It will use a unique local address, a ULA, but since IPv6 doesn't include its own IPv6 private address spaces, it's kind of a little bit more difficult. That's why it will use the ULAs. IPv4 has a different purpose. So with our IPv6 ULAs, these are meant for only local communication, so ULAs really aren't meant to be provided additional IPv6 address spaces. But it does provide protocol translation between IPv4 and IPv6, and that is what's known as our NAT64. And so what we can do is we can translate from an IPv4 packet to an IPv6 packet using address spacing. Though that's outside the scope of this course, it's one of those things that you should know how to do just in case you do actually have to translate between an IPv4 network and an IPv6 network. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.